Have you ever looked at the moon and wondered how it got there? Because I sure have, and so I looked it up. Now I'm going to tell you all about it. Let's go back in time. 4.6 billion years to be exact. To the moment the sun and everything else in the solar system started to form out of a giant cloud of space gas. Most of the gas collapsed until there was so much pressure that nuclear fusion started to happen in the core. And then there was light. The sun was born. So what about the rest of the gas? Well, there was only 0.2% left, but that was enough for interesting things to happen. For some time, all of the remaining stuff clashed into each other, forming bigger and bigger clumps until the first planets started to appear. Closer to the sun, the planets were smaller and more rocky. Further away from the sun, they were bigger and made out of gas and ice. Alright, so what about moons? Well, all the moons we know of are made of what was left but didn't get to be a planet, but instead started to circle around a planet. With the exception of Mercury and Venus, all the planets in the solar system have at least one moon. Even Pluto has moons. The remarkable thing about Earth's moon is that it is big compared to its parent planet, about 1/4 the size of Earth. And in fact, no other planet has a moon that big compared to its own size. So how did that happen? One theory for how a moon becomes a moon is that a smaller object gets caught in a bigger object's gravitational field as it flies by. But it's highly unlikely that that's how Earth's moon started to orbit our planet. Considering the sizes of the Earth and Moon, the two most likely outcomes are a collision, or they simply push each other away. Another possible explanation is that back when the Earth was still forming and molten, is that it was spinning so fast that a big chunk of it flew off and became the Moon. And a little fun fact for you, this hypothesis was proposed by George Darwin, the son of probably the most famous biologist to have ever lived, Charles Darwin. The problem here is that Earth would have needed to spin too fast for this to happen. Sorry, George. Another hypothesis is that the Earth and Moon formed at the same time out of the remaining dust and gas after the Sun emerged. But after the Apollo missions brought back moon rocks to study, it turns out the Moon doesn't have the same age, density, and composition as the Earth. So the one prevailing theory for the birth of the Earth-Moon system as it is the giant impact hypothesis, also known as the Big Splat. That's a lot easier to remember. At some point in the early days of the solar system, lots of so-called protoplanets circled the young sun. One protoplanet, roughly the size of Mars, crashed into proto-Earth. That massive impact sent trillions of tons of material into orbit, some of which escaped, but most of which later ended up forming the Moon as we know it. Computer simulations show that this collision was probably more like a graze rather than a full-on impact, because that probably would have destroyed both objects, since they were likely rather close in size. After the Moon formed, it orbited at about 1/10 of the distance it does today, and as time passed, it spiraled outward, and still does, and along the way it became tidally locked with Earth, meaning the same side of the Moon always faces us. The Moon also slows down and stabilizes the rotation of the Earth and causes the tides along with the Sun due to the gravity pushing and pulling the water of our oceans. And the whole planet, as a matter of fact. The effect is just much more noticeable with large bodies of water. Another interesting effect of the Moon slowly moving away from us is that in the distant future, total solar eclipses as we can see them today will no longer exist. We live in an era where the relative size of the Moon and the Sun in the sky is pretty much the same, so if you're at the right place and time, you can watch the Moon cover the Sun perfectly, causing one of the most spectacular natural phenomena anybody can ever witness. Millions of years ago, the Moon was too close, and millions of years from now, it'll be too far away, and whoever is alive then is never going to know what it was like to see a total solar eclipse. Food for thought. Alright, are you still with me? Because I have a bunch more moon facts for you. The Moon has a radius of 1,737 kilometers, and it's the 5th largest moon in our solar system, and bigger than any known dwarf planet. It orbits the Earth in 27 days, 7 hours, 43 minutes, and 11.5 seconds. Just to be precise. On average, the Moon orbits at a distance of 384,400 kilometers. The Moon moves away from the Earth at a rate of about 4 meters per century. The first human-made object to reach the Moon was the Soviet Union's Luna 2 uncrewed spacecraft in 1959. This was also the first human-made object to crash into any other celestial body ever. It was followed by the first successful soft landing by the Luna 9 in 1966. So far, only 12 humans have ever walked on the Moon. The surface gravity of the Moon is only 16.6% of Earth's gravity, so a person weighing 100 kilograms on Earth would weigh only about 16 kilograms on the Moon. During the Middle Ages and before the invention of the telescope, the moon was generally believed to be a sphere that was perfectly smooth. In 1609, Galileo Galilei used an early telescope to look at the moon and discovered it was not smooth at all, but in fact has many craters, valleys, and mountains. It wasn't until 1959 that anybody knew what the dark side of the moon looked like, and it was the Soviets' Luna 3 that made that first ever pictures. And although the quality was kinda bad, it was a historic event and the photos were published all over the world. And now I want to talk about the other moons in our solar system. Each of them are unique and some of them may even host life. Let's go back to our buddy Galileo Galilei. He lived in Italy from 1564 to 1652 and was an astronomer, physicist, and engineer, and is often called the father of modern science. Some of his best-known astronomical observations are those of various celestial objects through a telescope of his own design, including the Moon, Venus, Jupiter, and Saturn. He did in fact not invent the telescope, but he did improve them greatly to help with his observations. On January 7, 1610, Galileo pointed his telescope at Jupiter and saw what he described as 3 fixed stars, totally invisible by their smallness, all close to the planet. The following night, he peered at Jupiter again and noticed that the positions of these stars were changing. He concluded they were orbiting the planet. On January 13, he found a 4th tiny star. These satellites were independently discovered in Germany by Simon Marius later that month. He claimed he had discovered Jupiter's moons earlier than Galilei, but unfortunately he had no proof of that. Galileo wanted to name the 4 moons the Medicean stars, in honor of his patron and sponsor Cosimo II de' Medici, the Grand Duke of Tuscany. Other astronomers at the time were not happy with that decision, and Marius wanted to name the moons after lovers of the god Zeus, aka Jupiter, from Greek mythology. Galileo didn't like this idea and then just named the moons Jupiter 1, 2, 3, and 4. I guess that works. Astronomers used that naming system as far as the 20th century, until finally Marius's names started to grow in popularity. Io, Europa, Ganymede, and Callisto. The moons were named the Galilean moons in honor of the man that discovered them. Io is Jupiter's innermost moon. It's slightly bigger than Earth's moon and orbits the planet in about 42 hours. So far, 8 space probes have flown by and got a closer look at Io, most recently a spacecraft named Juno. And yes, Juno was named after Jupiter's mythological wife, coming to see what he is doing out there with all these beauties. Never let anybody tell you scientists don't have a sense of humor. Probably the most surprising discovery by Voyager 1 in 1979 was the presence of active volcanoes on Io. These volcanoes give the moon its striking colors and its thin atmosphere of sulfur dioxide. By orbiting so close to Jupiter and because of the pull of the other Galilean moons, Io experiences immense tidal forces, squeezing and stretching it like a giant stress ball, heating up the inside and causing constant eruptions, making this moon the most volcanically active object in the entire solar system. After Io comes Europa, orbiting Jupiter in about 3.5 days, and is the smallest of the 4 Galilean moons and slightly smaller than our moon. The surface of Europa is surprisingly young and smooth. That means there's only a few impact craters to be found, and reddish stripes and cracks crisscross all over the thick icy crust. From up close, the ice looks like sea ice on Earth, and there appear to be giant plates of ice that move like tectonic plates, causing the surface to renew itself. There are several clues to the possibility of a liquid water ocean beneath the surface, heated up by tidal forces, and protected from radiation by the thick layer of ice. And if there's liquid water, there could also be life. So far, there's no conclusive evidence for an ocean under Europa, but it seems to be one of the best places in the solar system to look for alien life forms. Next up is Ganymede, the largest moon in the solar system, bigger even than the planet Mercury, the only one with a magnetic field, and the only one of Jupiter's moons named after a male character from Greek mythology. Ganymede appears to be fully differentiated. That means its internal structure consists of a molten iron core, a mantle, a crust, and an ocean beneath the surface. This was in fact confirmed in 2015 after measurements with the Hubble Space Telescope of Ganymede's aurora. A large saltwater ocean affects the magnetic field and consequently the aurora. The evidence suggests that Ganymede's ocean might be the biggest in the solar system. This moon is quite the show-off, huh? In July 2021, water vapor was found in Ganymede's atmosphere, and so the moon is also a great candidate to look for alien life. And last but not least is Callisto, second largest of Jupiter's moons and orbiting at a much greater distance than the other 3. It takes almost 17 days for it to complete one orbit around its planet. Callisto's surface is one of the oldest and most cratered in the solar system, and it doesn't seem like there ever was any geological activity. The moon appears to have formed from the same gas and dust that formed Jupiter, and this slow formation and the lack of tidal heating from Jupiter's gravitational pull made that Callisto isn't fully differentiated. And so between a small rocky core and the crust, the interior is basically like a giant slushy in space. However, there is data that suggests that there might be a liquid water ocean in there after all. Because Callisto is far away enough from Jupiter that not much radiation from the planet reaches the moon, it's considered the best place to build a human base for future exploration of Jupiter and its moons. There are over 60 more moons orbiting Jupiter, all of them far away from the planet and considerably smaller than the big four, so I'm gonna leave this subject here because otherwise we could be here for hours. Let's move on to Saturn's moons. While Jupiter's major moons were discovered all at once by Galileo and Marius, Saturn's major moons were discovered over the course of more than a century by three of Europe's most prominent scientists, Christian Huygens, Giovanni Cassini, and William Herschel. The reason it took a while for these moons to be found is because Saturn orbits the Sun at almost twice the distance of Jupiter. So any light reflecting off of moons is much fainter, and so telescopes needed to be bigger and more refined for anyone to observe these distant objects. Let's start with the discovery of Saturn's biggest moon by Dutch mathematician, physicist, astronomer, and inventor Christian Huygens. Huygens is considered one of the greatest scientists of all time. He made groundbreaking improvements in optics and mechanics, including the invention of the pendulum clock, which was the most accurate way of timekeeping for the next 300 years. He was one of the founders of modern mathematical physics and often called the first theoretical physicist. Oh, and he also discovered Saturn has rings and it has a big moon. Inspired by Galileo, he designed his own telescopes with the help of his brother and so found a moon orbiting Saturn on March 25, 1655. Huygens simply named his discovery Saturni Luna, which is Latin for Saturn's moon. Very creative. It wasn't until 1847 that the moon would be officially named Titan, after a race of immortals from Greek mythology. Titan is the second biggest moon in the solar system and the only one with a dense atmosphere, made up of mostly nitrogen. And it's so dense that it blurs all of the surface, making Titan look a little fuzzy. It's also the only known body in space, aside from Earth, where stable bodies of surface liquid have been found. But because Titan's surface temperature is a chilling minus 179 degrees Celsius, there's no liquid surface water, but liquid methane. Titan has a climate, including wind and rain and seasonal weather patterns, and so has surface features similar to Earth, including dunes, rivers, lakes, deltas, and seas. Because of this, it's considered an astrobiological hotspot, meaning that it's probably one of the better places in the solar system to look for alien life forms. Huygens did not discover any more moons, but the contemporary Italian astronomer, mathematician, and engineer Giovanni Cassini discovered no less than 4 new moons orbiting Saturn. Cassini lived and worked in France at the time, as director of the Paris Observatory under King Louis XIV. On October 25, 1671, he discovered a small moon orbiting Saturn, that will later be named Iapetus, another Greek titan. For some strange reason, Cassini only saw the moon on the planet's west side, and it wasn't until 34 years later that he finally found the moon on the planet's east side, where it appeared 6 times more vague. Cassini figured that the moon had to be tidally locked and had a brighter side and a darker side. And he was right. NASA's orbiter Cassini, named after the scientist, was sent to explore the Saturn system and discovered that the moon indeed has a bright side and a dark side, and a giant ledge along its equator, making it somewhat walnut-shaped. In 1672, Cassini discovered another moon of Saturn, later called Rhea, after the mother of the gods. Studies and flybys of Rhea and other moons of Saturn show these objects consist mostly of water ice, kind of like giant snowballs in space, and so they're all highly reflective. Still, Rhea orbits 50% closer to Saturn than Titan, so the small moon is outshined by the big planet, and its discovery is a testament of Cassini's skill as an observer and the advancements in telescopes and optics at the end of the 17th century. In 1684, Cassini found 2 more of Saturn's moons in one night, Thetis and Dione. Modern research of these little moons show that they are also mostly made of water ice, and their surfaces are ancient and full of impact craters and ridges, and don't seem to have changed at all in billions of years, out there in the cold depths of space. Theseus's most prominent features are a giant impact crater called Odysseus, which is nearly 2/5 of the diameter of the moon itself, and a huge valley called Ithaca Chasma that is 100 kilometers wide and over 2,000 kilometers in length. Dione is best known for its wispy terrain, which turned out to be massive ice cliffs, some of them several hundred meters tall. Finally, we're getting to William Herschel, the English astronomer and composer that found 2 more moons orbiting Saturn in 1789, over 100 years after Cassini found Thetis and Dione. Herschel was an active astronomer and often collaborated with his sister and fellow astronomer Caroline Herschel, and he built his own telescopes for in-depth study of the night sky. He also happens to be the first human ever to discover a new planet in the solar system, Uranus, and 2 of its moons. Herschel found his first Saturn moon, Enceladus, using his brand new telescope that was 1.2 meters in diameter and 12 meters long, at the time the biggest in the world. Enceladus appears faint due to the close orbit to Saturn, and it's hard to observe with smaller telescopes. Herschel made his observation during a Saturnian equinox, when Saturn's rings face Earth head-on, so there's much less glare from them. In reality, Enceladus has a smooth, icy surface and is extremely reflective, almost 100%. The moon is geologically active, and there's so-called cryovolcanoes near the South Pole that eject plumes of water vapor and hydrogen and bits of ice. Some of this falls down as a kind of snow, the rest of it escapes into space and forms Saturn's E-ring, the vague outermost ring of the system. It seems gravitational pull from the planet and other moons provide the energy that warms up the interior of Enceladus and causes this volcanic activity. And there appears to be evidence for a subsurface ocean. Once again, really, the solar system seems to be full of bodies of water. The other moon that Herschel discovered is Mimas, a funny little moon with an enormous impact crater that kinda makes it look like the Death Star from Star Wars. The striking similarity is just a coincidence though, since the big crater was discovered by the Voyager 1 in 1980, 3 years after the first Star Wars movie was made. Mimas has a diameter of only 369 kilometers and is believed to be the smallest astronomical body that still has a round shape due to self-gravitation, meaning it's just big enough for its own gravity to shape it into a ball. And it really is tiny. The surface area is slightly less than the land area of Spain. Mimas' massive crater is named Herschel after the person that discovered the moon. And there is a ton more small irregular moons orbiting Saturn, at least 82 in total. Before we move on, I would like to mention shepherd moons. They're tiny moons that orbit within or just beyond the planet's ring system and have the effect of sculpting the rings, so to speak. They give them sharp edges and create gaps in between them. One theory of how Saturn's spectacular ring system formed is the shattering of one or more icy moons into small pieces, and the gravitational pull of the planet and all the moons keep the rings in that shape, at least for now. Research suggests that the ring system is very young in astronomical terms, anywhere between 100 million and 10 million years old, and they may disappear completely in the next 300 million years. Let's move on to Uranus's moons. William Herschel discovered Oberon and Titania in one night in 1787, but didn't name them at the time. In 1852, William's son John suggested these names at the request of William Lassell, the English astronomer who found 2 other moons of Uranus, Ariel and Umbriel, and these are the names we still use today. For the first time, these newly discovered moons were not named after figures from Greek mythology. Oberon and Titania are the king and queen of the fairies in Shakespeare's A Midsummer Night's Dream, and Ariel and Umbriel are characters from a poem by Alexander Pope. Not all that much is known about Uranus and its moons, since the system had been studied up close only once, by the Voyager 2 in 1986. The simple reason is that the Uranus system is really far away, on average 3 billion kilometers from the Sun, while Saturn sits at only about 1.4 billion kilometers, and Jupiter a very reasonable 780 million kilometers. The closest approach by Voyager 2 of Oberon was about 470,000 kilometers. And we have pictures of about 40% of the surface. The moon appears to be made up of mostly rock and ice. Its surface is rather dark and slightly red in color, and it's littered with craters and chasms. Likely, Oberon and the other major moons were formed from leftover material shortly after Uranus's formation. Titania is the biggest of Uranus's moons and the 8th largest in the solar system, and also made up of mostly ice and rock. Infrared images of the moon revealed the presence of water ice and carbon dioxide on the surface, which suggests that the moon could have a thin atmosphere. Its most striking features are these huge cliffs and chasms, and scientists think the moon's surface cracked once it started to cool down after its formation. Ariel, a much smaller moon than the other two, has a complex surface with many craters and a system of canyons and ridges. The moon shows signs of more recent geological activity than other Uranian moons, possibly caused by tidal heating. Umbriel is the darkest of Uranus's moons, heavily cratered, and has one major distinct feature, the crater Wanda, named after a dark spirit from Australian Aboriginal culture. For some unknown reason, the crater has a bright ring of material inside of it. It may be a deposit of carbon dioxide ice. And the final of Uranus's major moons is Miranda, and the reason I'm only mentioning it now is because it wasn't discovered until 1948. It was named after a character of Shakespeare's play The Tempest. Miranda is a tiny icy moon with one of the most extreme and varied surfaces ever observed in the solar system. It almost looks like it was torn apart by something and messily put together again. And so we finally reach Neptune. Neptune is invisible to the naked eye and so wasn't discovered until 1846. The discovery of yet another planet meant that the moon hunters among astronomers had a new quest, finding a moon orbiting Neptune. The honor went to William Lassell. Lassell was a British businessman that had made astronomy into his full-time hobby after he retired. He had made a fortune brewing and selling beer and used his money to build his own observatory. He built the at the time biggest telescope in the world, and it was William Herschel's son John that suggested to Lassell to use that telescope to look for moons orbiting the newly discovered planet. It took Lassell only 8 nights of observation to find one. There was something funny going on with this moon. It appeared to be orbiting backwards, retrograde, unlike any other moon in the solar system. And it has an unusually tilted orbit compared to Neptune's own orbit. Lassell did not name his discovery, but the moon was later named Triton, the son of the sea god Poseidon, the Greek equivalent of Neptune. There isn't much known about Triton, since the Voyager 2 was the only spacecraft to pay a close visit in 1989. The Neptune system sits at about 4.5 billion kilometers from the Sun. Again, hard to reach. Triton is quite big and bright, with a reflectivity between 70 and 80%. Surprisingly, it appears to have a thin nitrogen atmosphere, active geysers, and a geologically young surface. Triton's western hemisphere shows a strange series of fissures and depressions resembling the skin of a cantaloupe melon, and so it's dubbed cantaloupe terrain. Because of its retrograde orbit and composition, scientists think that Triton was captured by Neptune from the nearby Kuiper belt and is like some kind of twin of Pluto. And so that concludes... Wait a minute. Didn't I say all the planets had moons except Mercury and Venus? What about Mars? You would think that with all these moons being discovered at the very edges of our solar system, somebody would have bothered to look for moons around Mars. But nobody really did for a long time. That was until the American astronomer Asaph Hall decided to do it. Few other astronomers had made serious attempts at finding Martian moons, but to be fair, it wasn't an easy job because of the intense glow of the planet. Luckily, Hall was also professor at the US Naval Observatory, so he had access to the biggest telescope in the world at the time. He waited until Mars was in opposition, and on August 11, 1877, he saw a vague object near Mars. In the following nights, he observed the object was indeed moving with Mars along the sky, and he found a second object, so he could confirm he had found 2 moons orbiting the planet. A colleague of Hall suggested he name the moons after the sons of the Greek war god Ares, aka Mars, the god of dread Deimos, and Phobos, the god of fear and panic. Fun names. Because neither of these 2 moons have been explored by any probe, despite a bunch visiting Mars itself, not all that much is known about them. Deimos is tiny and irregular, and not nearly big enough to become fully ball-shaped under its own gravity. It's quite smooth, and nothing much really stands out about it. Scientists think that it was either a captured asteroid from the asteroid belt, or it formed alongside Mars from the same material. Phobos is bigger but still irregular, and orbits its planet closer than any other known moon. So close, in fact, that it orbits faster than Mars spins around itself. Phobos takes only about 7.5 hours to orbit the planet, while a Martian day lasts for 24 hours and 39 minutes. So that means that an observer on the planet's surface would see the moon rise in the west, move across the sky in about 4 hours and 15 minutes, and set in the east twice a day. Phobos is one of the least reflective objects in the solar system, and its defining feature is a large impact crater called Stickney, after Asaph Hall's wife Angeline Stickney, an academic, suffragist, and mathematician. Now, if you've been paying attention, you may remember that I said even Pluto has moons. Now, Pluto wasn't discovered until 1930, and its largest moon, Charon, wasn't found until 1978, almost 50 years later. Not much was known about these objects at the edge of the solar system, until the NASA probe New Horizons finally reached it in 2015, after traveling for over 9 years. Charon has a radius of about 606 kilometers, and is about half the size of Pluto itself. And so some scientists argue that the Pluto-Charon system is actually a double dwarf planet system. Also because the barycenter, the center around which the two objects orbit, lays outside of Pluto. The system is also unusual because both objects are tidally locked to the other, meaning they always have the same hemispheres facing each other. Charon was named after two people, one fictional and one real person. That real person is Charlene, the wife of the discoverer of the moon, James W. Christie. But the name Charon can also refer to Charon, the mythological ferryman of Hades, who guides souls across the river Styx, the divide between the world of the living and the world of the dead. 4 more small, irregular moons orbit the Pluto-Charon system. Nyx, named after the Greek goddess of the night, Hydra, after the 9-headed underworld serpent from Greek mythology, Kerberos, named after the 3-headed hound of Hades that prevents the dead from leaving the underworld, and finally Styx, named after the mythological river of the dead. Sadly, New Horizons was not able to get good pictures of these tiny moons during its flyby, so all we have is these potato quality pics. I mean, it's still better than nothing. It's already mind-blowing that the technology even exists to get probes that far into the solar system, let alone take pictures and send back to Earth. It's amazing. And so with these moons being discovered around dwarf planets, scientists started to wonder if an object needed to have a minimum size in order to have a moon. Telescopic research in the 1970s and 80s seemed to hint at the possible existence of moons orbiting asteroids, but there was no definitive proof until 1993. The NASA probe Galileo made a flyby of asteroid 243 Ida that resides in the asteroid belt between Mars and Jupiter, and it was discovered that Ida had a teeny tiny moon. Since then, hundreds of moons have been found orbiting dwarf planets and asteroids. Scientists suspect that most of these irregular little moons are likely debris of impacts or collisions that got caught in the parent's body gravity. And so that concludes my tour of the moons of the solar system. Now, I would love to talk about moons outside of the solar system, but as I'm making this, nobody's found and confirmed a so-called exomoon orbiting an exoplanet. Thousands and thousands of exoplanets have been discovered though, so it's only a matter of time before somebody finds a moon and actually is like, yeah, that's a moon orbiting a planet outside of the solar system. It's just incredibly difficult to do because all of these objects are very, 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 very far away. But considering the amount of moons that have already been found in our own solar system, it looks like it's a discovery that is just waiting to happen. That's pretty exciting. So I hope you enjoyed this video. I hope you learned something new because I learned many new things. And that's the whole point of this channel, learning new things because I love doing that. Let me know in the comments what your favorite moon is. I'm kinda stuck between Io and Titan, to be honest. They're both like really awesome. Although Enceladus is like really awesome as well with the cryovolcanoes. I didn't even know that existed. Anyway, let me know what you think and I will see you in the next video. Bye!